Take the derivative as a product, which is 2x times sine of 3x. Sine has an inside, which is 3x, and the outside is sine. So we take the derivative, it's going to be the g, which is sine of 3x, multiplied by the derivative f, which is 2, plus f, which is 2x, multiplied by the derivative of g. Derivative of the inside is 3. Derivative of the outside is cosine. Keep the inside the same. And then rewrite y prime as 2 sine of 3x plus 6x cosine of 3x. Inside function is cosine of x, outside is tangent. Derivative of the inside is negative sine x, multiplied by the derivative of the outside, which is secant squared, keeping the inside the same of cosine of x. Then just rewriting the problem, negative sine x, secant squared of cosine of x. Rewriting the problem is 3x squared plus 2x plus 1 to the 1/2. The inside is the 3x squared plus 2x plus 1, and the outside is the 1/2. Taking the derivative of the inside will be 6x plus 2, keeping that in parentheses. Derivative of the outside is 1/2, keep the inside the same. The new exponent is negative 1/2. Distributing the 1/2, 3x plus 1. The inside function is this quotient. The outside is the 3. The quotient has a low and a high, so we're going to take the derivative of the inside, so we'll take low, which is sine of x, d high, which is sine of x, minus the high function, which is 1 minus cosine of x, times the derivative of the low function, which is cosine of x, all over the low function sine of x squared. Then we'll multiply by the derivative of the outside, bring the 3 in front, keep the inside the same, and the new exponent is 2. Simplifying the problem, we have sine squared, distributing to get negative cosine of x plus cosine squared x, all over sine of x squared. Distributing the squares, we have 1 minus cosine x squared over sine of x squared. Changing sine squared plus cosine squared into 1. Rewriting the problem, so we have 3 times 1 minus cosine of x cubed all over sine squared x, which is actually 1 minus cosine squared x. Changing the other sine squared x also into 1 minus cosine squared x. Then we'll factor the denominator. 1 minus cosine squared becomes 1 minus cosine x times 1 plus cosine x. Same thing with the other one. Then we can reduce the 1 minus cosine of x to leave us with 1 minus cosine x on top. 2 of them on the bottom, eliminating 2 of them on the top. And down on the bottom we have 1 minus cosine of x quantity squared. We're going to write the equation of a tangent line, which is y minus y1 equals m times x minus x1. We have the given point, so we'll put in the y value and the x value. And now we'll get the slope, take the derivative. We have a product rule. So here's g, 1 minus 2x to the third, multiplied by f prime, which is 1, plus f, which is x, multiplied by g prime, which is a chain rule. Derivative of the inside is negative 2. Derivative of the outside is 3 times 1 minus 2x squared. Rewriting the problem, we have 1 minus 2x to the third, minus 6x times 1 minus 2x to the second. We need to evaluate the slope at the x value of 1, so substituting in the value of 1 for x. Then evaluating to get negative 1 to the third, minus 6 times negative 1 to the second, which comes out to negative 7. So the equation of a tangent line is y plus 1 equals negative 7 times the quantity x minus 1. We're going to take the second derivative. We have a chain rule. We have an inside function, which is x over 2, which is the same as 1/2 x. So taking the derivative of the inside will be 1/2. Then the derivative of the outside is negative 2 sine, and then keep the inside the same, so it's x over 2. Simplifying to make negative sine of x over 2. Now to do the second derivative, chain again. Derivative of the inside is going to be 1/2. Derivative of the outside is going to be cosine. Keep the inside the same.